So everyone, please open your server. So this side you have the EIB demo server. This side you have the new server when it's given to you. So the first thing we are going to do is you go to upload the file. Do it again. So you upload the file, and then you choose local file, and then from here you go to the folder GS Galaxy Demo. There are a few folders. So the first two I'm going to show you called the BLUP and the BLUP. So there is one file. So you just take this file here, and from the type is type delimited. So once you type in type file, okay, then you start. So once you push it, this will be turning, and once it becomes green, means that's already available. Okay, is everyone ready? The here is if it's green, and from here, what you can do is there is icon. You can preview the file, you can modify it, and you can remove it by clicking on each the button. And you can also click, and from here you can download, and you can look at the information. Okay, so this file I'm going to run, and while running, we'll look at what's in the file, and we'll look at what's in the inputs, in the output. Okay. So the first tool I'm going to show you is called a BLUP and BLUP calculator. This is one important tool to really pre-process your phenotype. So you just click on this tool, okay, and the file already in the format will be showing here. So it's automatically put. If not, you drop down, you just choose the file you want. So this is phenotype. So in this tool, we can have two different type of design. One is row column type design with letters. Another design is RCBD, random complete block design. So in my file is RCBD, and then you can look at your replication factor in your trial design in this file. So together with me, let's choose the name of the experiment or the name of the location. Either will be fine. So here, let's do together name the experiments, because that's the true replication factor. Is not the rep in my file. Is everyone with me? So RCBD, and then choose column 1, name my experiment as replication factor. The next to choose is genotype column. The genotype here just means the accessions or the line, what's the germplasm. So in this file, what we have as a line name actually is the sample name in my genotype GPS. So choose column 18, sample name in GPS data. Okay. Then the Y column here actually is the Y response variable. That's in this file. I have several, but the one for the demo purpose, I'm going to choose the column 13. That's the green yield. Okay, choose GY. And then to summarize the GBV or BLUP blob, sorry, I said wrong thing, the BLUP blob, you can choose summarize variable by. So in my file, I can choose that as a season. I have 2 seasons, May season, off season, or you can choose based on the management. I have the optimum or the drought. So you can choose either. So here I'm going to choose the management. All right. Is everyone on the same page with me? I don't want to make it too complicated. So this one can look at other variables. I will choose no, variable 1, variable 2, no. And if you choose no, and you are ready to submit this job called execute, okay? I just submit, and then it's going to start run. And then I will now show you the input file, and we'll look at the output file, okay? Any questions from the tool and the parameter selection steps? Yeah. So if you say you want to look at what did you run with, what you can do is I have several output files. You can just click on it, and then you can run the refresh. Yeah. So actually, I want to remind you is you want to log in, and you also turn this on. Okay. This one enable, disable, so allow you to go between your file and also your user interface. Okay. So this button, this is called run this job again. Since you want to see the parameters what I chose, I will run this again. It will bring you back for the parameters we chose. Okay. So the parameter we chose is the first is the one file from your flash drive. The design is RCBD, and the replication I chose column 1. Name of the experiment, because I have 7 experiments here actually for the same the same set of germplasm. They are the replication factor. The genotype here I chose the column 18. That's the sample name. That's the genotype. And then the Y is the column 13. That's the green yield. And the summarized by I chose column C7. That's the management. And everything else I just chose no, and then submitted as execute. Is everyone with me? If you're not, raise your hand. Other people all have this run correctly. So I would like to take a look of the input file, so you know what's in the input file, what's in the output file. So the blue blob, you click on it, then you can click on the download button, download. So from here, you click on the download button, and then so each of the number is the job ID. So you can see Galaxy Job 9. Open that up. So that's already in Excel file. So you can see you have it shows like 381, basically 380 how a header, and then they come in summarized by management. So management has managed the drought and also optimum. So I have 190 samples and then tested under drought and then optimum. And you have the output of the green yield for blue, green yield calculated as a predicted BLUP, and also prediction error variance, and also the reliability, and then you also have the means, just the simple mean for all the entries. So this is your blue blob calculated values in the output. So let's take a look of the input file to see if this makes sense. So open your input file. So input file, you can see here the name of experiments. I have -1 all the way to -8 with a file, -file, that 12 missing. And it was tested in the year 2010, the season column, May and off season, and the name of the location, and the countries, Kenya and also Tanzania, and the collaborators. So this is based on the modified test data sets from Mike's program, the network from Simon Maze. So you have location and the red factor here, the block, and the entry number is where you got from your trial data. And then we have 4 columns phenotype, basically observations for yield, AD, plant height, year height. And then because we do not have the data management system, we manually merge the GIDs. This GID is the sample GID, not the hybrid GID, even though the trial data were from the tested. Basically, the lines on tester, and you have the sample name in GBS data, the pedigree, etc. So these still required a little bit of manual merging with pre-process to give to you. So any questions what you see in this input phenotype file and also the output for BLUP calculator. Yeah. Right. Okay. So from the UI side, first you need to understand your yield trial or your phenotype, any kind of design, right? So here, my design, I think this will tie up with the output file as well. Yeah. So we have the user documentation for the Y was in the model. So that's the germplasm and the replication factor and a random error. Also, if you have the BLUP factor, you can add that in, okay, and random. So if you choose variable 1 and variable 2, you have the interaction. If you are now choosing any, like what I did, just summarize by one of the major grouping, either season or management, you will look at all these samples tested under those reps and then predict or estimate. So BLUP, biased linear unbiased estimate as BLUP, and BLUP is biased linear unbiased prediction. So based on your phenotype, you can look at different variables in the model. You can estimate, you can predict. Okay. So in our output file, basically is I look at 4 trials. They were placed in optimum, and the 4 locations maybe is optimum, and the 3 locations was drought. And I look at the mean, or I get the estimated, I get predicted. And this column show you the predicted error variability. And then this column, the PV reliability, show you the reliability. So the higher in this column, the better, okay? And then your BLUP and BLUP, you want to compare that with your original observed data, and you also want to look at how close these are. And then with your sample, right? So you have the 190 samples placed in drought, or so let me do the filter. You can see how different if you want to filter them based on the management. So for example, if I just short based on my samples, so you can see the sample, if I'll summarize based on the 3 drought environment or the 4 optimum environment, you can see the pattern always under drought is much lower than the optimum, right? So in this kind of pattern. So this, in this scenario, I think our mean is exactly the same as the BLUP, but it's different from the BLUP. Is that good? Okay, so if this is good, we are going to show you the second major tool. That's called a GOBii calculator. Okay, GOBii calculator will use your calculated BLUP and also your marker matrix, bring these together, give you another factor to estimate your breeding value. That's why genomic estimated breeding value. It's not only based on your phenotype. So the model we have here is a 2-step approach to use your calculated phenotype, not just the simple mean, even though in this scenario it's the same as the BLUP. But looking at your response already adjusted, already calculated, and put together with your marker matrix and estimated breeding value. So if you think the BLUP is like GCA in some way, the GOBii will be better GCA, general combining ability, because you're looking at your lines, how they perform across different locations, and also adding the marker